Hi guys, this is a video which is going to be going through some stoichiometry calculations. I'm just going to do a whole bunch of little calculations for you just so you can get an idea of how to actually do them. And for each of them I'm going to be reminding you of each of these steps. Okay, so you've got to remember the 6 steps that we're going through. So really want you to remember to balance equations first, and that is really the key. If you can't balance your equations, you've got to go back and practice them until you can get them right. Okay, that's really key. Then write down what you know. So sometimes it's good to highlight the information in the question, right, and write that down underneath. That's what I'm going to be doing. Then calculate the number of moles for the known. Okay, the known that you're going to be using, okay, is the one you've generally got 2 values for. Okay, work out your mole ratio. Okay, so the mole ratio is the using the numbers in front of your chemicals from the balanced equation. All right, so it's whole numbers and it's unknown over known. Okay, then you calculate the number of moles for the unknown, and that's quite simple. That's just calculating step 3 by step 4, and then you need to find your answer. Okay, remember to put your units at the end, because quite often people go all the way through and what they forget to do is actually put their units on at the end. So remember that is quite important. Helpful tip I'm going to give you is do not round off or clear your calculator as you go. Okay, when you get to the end, and quite often you'll find in the exam you'll get step by step for each of these. Okay, and a common mistake is either rounding off your answer or clearing your calculator. If you do that, you'll end up carrying your error through to the end, and you'll find that your final answer will be incorrect. So make sure you don't do that as you go. Alright, so I'm not going to refer to this again in the coming videos. I'm just going to quickly just simply show you this screen and remind you of what you need to do, okay, and then get straight into the calculation. So make sure you know these, make sure you practice doing these, okay. So first one I'm going to do is this one here. So we've got calculate the mass of calcium carbonate that reacts completely with 50 ml of nitric acid solution of concentration 0.25 moles per litre. Well, the first step, as always, alright, is going to be a balanced equation. Okay, so what I'm going to do is I'm going to write up my equation. So I've got calcium carbonate here, alright, calcium carbonate, and we're reacting that with nitric acid solution, HNO3, and you've just got to know what you're doing here. So I'm just going to make that 3 a little bit clearer, alright. And from this is a acid carbonate reaction, so we get a salt, which in this case is calcium nitrate, we get water, and we get carbon dioxide. Okay, to balance this up, we've got 2 nitrates over on this side. I've got 2 hydrogens here as well. We're just going to put a 2 in front of that. I'm not going to go through balancing equations this one. Look at the other videos if you need to. Then what you do is you have a look at what information you've got, all right, in your actual in your question here. So over here we've got 50 ml of nitric acid, okay, and we've got a concentration of 0.25 moles per litre here. Okay, so what we're going to do is we're going to write the information underneath. So we had volume of 50 ml, so volume of 0.0500. Really important to remember that you need to convert your volume into litres. Okay, and we've got a concentration of 0.25 moles per litre. So our concentration here, 0.25 moles per litre. So that's writing down what we know from the equation. What we're trying to do is calculate the mass of calcium carbonate. Now, using our equation, all right, to calculate mass, we need to know number of moles and we need to know molar mass. Okay, so we need to work out the molar mass of calcium carbonate, and we get that off the periodic table by adding up the mass of calcium plus a carbon and 3 oxygens, and that works out to be 100.09 grams per mole. So what we've done through is we've done the first 2 steps. We've got our balanced equation, okay, we've got written down what we know, and we've got that from our equation up the top here. Okay, now we go on to the next step, which is calculating the number of moles of our known, and our known is the one we've got 2 values for. Okay, here we've got 2 values for nitric acid, so we're going to be calculating the number of moles of nitric acid. Okay, using our equation, N equals C times V, so make sure you know how to use that one. Okay, so the concentration is 0.25 and our volume is 0.05. Okay, so you can work that out if you want, but that's not really what the question is asking us. If this was part of the exam, you'd go through and you answer it. Okay, but for the moment we don't actually need to worry about it too much. So what I need you to do is to make sure you keep in mind that our number of moles here is 0.25 by 0.05. Okay, then we go to the next step. Alright, the next step is calculating our mole ratio. Okay, so our mole ratio is our number of moles. So I'm just going to go back to black on this one. Number of moles of our unknown, which is what we're trying to work out, which in this case is the calcium carbonate, over the number of moles of our known, which was the nitric acid. Okay, so if you have a look at the equation, out the front of the calcium carbonate we had a 1. Out the front of the nitric acid we had a 2. So the mole ratio is actually 1 to 2. So what this is telling us is that for every 1 mole, alright, of calcium carbonate, we need 2 moles of nitric acid to react with. Okay? So that means our number of moles of calcium carbonate, which is step 5 now, okay, is the number of moles of nitric acid that we used times by 1 over 2. Okay, so because we use our mole ratio of 1 over 2, okay, up here, we just take that value straight down here and we multiply it by the number of moles of nitric acid that we calculated previously. Okay, so that's going to be 0.25 times 0.05. That was the number of moles of nitric acid I asked you to remove from the last slide. We're going to multiply that by half. Okay. Now again, we could work that out if we want to, and if it's an exam question that asks you to work it, but we're just trying to get through to the final mass. So if you remember what we determined, the mass of calcium carbonate is going to be number of moles times molar mass. So we now know our number of moles, which is here. So we're going to put that into our equation here, and we know the molar mass that we had from earlier, alright, which was 100.09. So it's 0.25 times 0.05 times 1 over 2. That's the number of moles from up there, and we're going to multiply that by a molar mass of 100.09. Okay, if you put that into your calculator, remember if you've been doing this step by step to answer the previous ones, you don't round off. You should have hopefully got a value of 0.63 grams. Okay, now that's to what we call two significant figures. Alright, I'm going to talk about significant figures in another video, but if you just quickly go back and have a look at the question, alright, up here what we had is 3 significant figures here with our nitric acid and 2 significant figures here for our concentration. You always give your answer to the least accurate of significant figures, in which case was 2, which is why over here we've given our answer down here to 2 significant figures. So that's the first one. Hopefully that's helpful. That one's been a little bit longer than I normally do. The next ones we're going to start to go through a bit quicker. But hopefully that gives you an idea of using the steps, alright, and you'll find that quite useful. Alright, thanks guys. Encourage you to maybe go back, try it again and pause it before I actually start going through the calculations. Make sure you can do it and get the same answer, and then go on to the next ones. Okay, see ya.